Hey everybody, it's Miss Parsons. Today we're talking about applications of linear inequalities. So your favorite thing in the world, story problems. So first we got to talk about constraints, and those are limitations or restrictions that can be modeled with inequalities in two variables. So you're looking for keywords like at most, at least, the greatest. Those words offer constraints for our problems. So in problem one, suppose Inez plans to save all the quarters and dimes she gets until she has at least $5. Okay, so there is that constraint there, at least. So we're going to represent this scenario as an inequality. So I've got two things I'm talking about here. I'm talking about quarters and dimes, and I'm talking about at least $5. So I have to put this as a monetary value. So I got to think, what is a quarter worth and what is a dime worth? Well, a quarter is worth 25 cents. So I'm going to put 0.25 per quarter. So I'm going to use Q plus, because when we count money, we're adding dimes. So that's 0.10 per dime. And I know that there's a constraint where it's $5. So I got to think about what at least means. Does that mean that it's going to be greater than, less than, greater than or equal to, or less than or equal to? Well, at least means that's the minimum. So I know that this value has to be greater than the $5, but then I got to think, okay, can it be $5? Would we be okay if it was exactly $5? And yes, we would. So it is greater than or equal to $5. Ike is applying to a cooking academy. As part of his application, he must take a test and submit an essay. His essay score, we're going to use E, will be tripled and then added to his test score. The total must be at least, there that is again, 200 for Ike to be accepted at the school. Write an inequality to represent the situation. Okay, so his essay score is going to be tripled. What does that mean in terms of math? Well, triple means 3, and if it's being tripled, I'm multiplying it 3 times. So that's 3e, and then added, that's a plus sign, to his test score, t. And I know that there's a constraint and 200. So I got to think, what is that constraint going to be compared to this value? Well, at least, just the same as above, it needs to be greater than or equal to. He could score 200 and still be accepted at the school. So it is a greater than or equal to sign. So remember when we're graphing inequalities in two variables that it's a dotted line if it's greater than or less than. It's a solid line if it's greater than or equal to, less than or equal to. So just a reminder, if I'm going to graph this inequality, first thing I'm going to have to do is solve for y. So I get plus 2x plus 1. Okay, so if I graph that, I put a dot at 1, up 2 over 1. And is it dotted or solid? Well, I look at my inequality. Oh, that's a greater than sign, so I know that it is a dotted line. Okay, so I run that dotted line all the way through. Choose a test point to determine whether to shade above or below. You can do that, or we can always remember, since we normally graph in y equals mx plus b, if it's greater than or greater than equal to, we're going to shade above. And if it's less than or equal to, we are going to shade below. That's a super easy way to remember. So in this case, I have a greater than, so I'm going to shade above. Okay, so just a little recap of that. So we're going to be using that. All right, so Gordon earns $10 an hour mowing lawns, $15 an hour tutoring. He plans to earn at least $300 a week doing these jobs in the summer. So I'm going to write an inequality here Okay, so I got to define my variables. So I'm going to say that y is mowing lawns and x is tutoring, just because we're used to x and y. So we're talking about money, so money goes with money. So I've got $10 an hour mowing lawns plus $15 an hour tutoring. And I know it has to be at least, so that's our greater than or equal to $300. Let's graph this on the coordinate plane. So let's see, I'm going to solve for y. So 10y is greater than or equal to negative 15x greater than, or sorry, that's wrong. I don't have an eraser. Plus, that's a plus sign, 300. And then I'm going to divide by 10 on both sides, just getting this into slope-intercept form so it's a lot easier to graph. And so I'm going to reduce this fraction, negative 3 over 2, and plus 30. All right, so let's see. I'm going to count by tens, I think. 10, 20, 30, 40, 50, and 10, 20, 30, 40, 50, and so on and so forth. So I'm going to start at 30 because that's where my B is. I'm going to go down, okay? Since I'm counting by tens, I can actually make this ratio, just for time's sake, 30 over 20. And it still works because this would reduce down to 3 over 2. But since I'm counting by tens, this makes it a little easier. So I'm going to down 3 and over 2. Okay, and it is a solid line. And I'm going to shade up. How did I know how to shade up? Give you a second, think about it. How did I know I was shading up? Okay, well, because of that greater than sign, I know that if I am a greater than, then I'm shading above the line. Okay, a television quiz show awards 4 points for each right answer and deducts 2 points for each wrong answer. Ms. Foy wants to score at least, there's that constraint again, 80 points. Which statement about this inequality is true? Okay, so we know we have 4 for each right answer and deducts, that's subtraction, 2 points for each wrong answer, and she needs at least, that's greater than or equal to 80 points. So which one of these is true? Let's see. Well, it's B, because that matches the inequality that we wrote. So we know that A and C are not right. Let's look at D, E, and F. If she gets 24 questions right, she can get no more than 8 questions wrong to score at least 80 points. So let's plug this into our equation and see what happens. I've got 4 times 24 minus 2 times 8, and that's going to be greater than or equal to 80. Let's see if this works. So 4 times 24 minus 2 times 8, that gives me 80. It's greater than or equal to 80. Okay, that's true. Okay, if she got any more than that, this number would go down. Okay, so this is true. If she gets 20 questions wrong, she must get no less than 30 questions right to score at least 80 points. So let's try this one. We've got 30 questions right and 20 questions wrong. Let's see how this works out. Okay, 4 times 30 minus 2 times 20. And that gives me 80 again. It's greater than 80. Okay, if she got any more questions, no less than 30 questions. Yeah, if we got 29 questions wrong, this number would drop. So this is true. And if she gets 15 questions right, so 4 times 15, she must get at least 20 questions wrong to score at least 80. So let's check that out. 4 times 15 minus 2 times 20. And that's 20 is greater than or equal to 80. So this one is not correct. So B, D, and E are all those, and we check those by plugging in. All right. So there are no questions now following this video. So you are done. Give yourself a pat on the back.